Backhaul nodes. In wireless LAN, there may be a chance that the information may be returned to the wired access point. Getting back the information to access is called backhaul. Small networks can be handled without any special configuration, whereas in larger network, backhaul nodes are required to retrieve the information from wired access node. Protocol layer and functionalities. Factors that influence the performance of wireless mesh networks include architecture, topology, data pattern and traffic, density of the nodes, number of channels used by the nodes in the network, transmission power, mobility of the nodes, architecture, topology, data pattern and traffic, density of the nodes, number of channels used by the nodes in the network, transmission power, mobility of the nodes. In order to develop the protocols, we need to clearly understand the relationship between the above factors and the capacity of WMNs and is given in layer structure of WMN. Wireless mesh networks are capable of multiple data rates simultaneously. It is achieved with the help of various modulation techniques and coding rates. Link adaptation provides adaptive error resilience. High-speed data transmission is achieved with orthogonal frequency division multiple access, OFMA, and ultra-wideband, UWB, techniques. Wireless communication system is provided with smart antenna for the purpose of increasing the capacity and to overcome the co-channel interference, fading, multi-antenna systems, etc. But it is tedious for designing the same for wireless mesh networks, though it is available with the existing system. Unoccupied spectrum can be utilized by proper frequency planning with the help of WMN. Frequency agile/cognitive radio is used in order to utilize the unused spectrum. As most of the radio components, RF band, various channel modulations, and access modes are programmable in such a way that it can be implemented in a software for working under cognitive radio range. It will be easier if further updating is to be carried out. With the available physical test beds, the software platform is not much appropriate to provide desired solution. But still it can able to make advanced changes in physical layer techniques which suit better for wireless communications. MAC layer in WMN plays a unique role when compared to various other wireless networks. In WMN, communication is focused on more than one hop rather than single hop with the help of MAC. Multi-point to multi-point communication is possible with the help of distributed MAC. Self-healing and self-organization of node are the prime requirements of WMN for better performance. Communication between the node and the node which are located far, multi-hop distances, from the source node should be proper for providing better stability. Even less mobility influences the system performance of MAC. MAC protocol is designed in such a fashion that WMN can work simultaneously with both single and with multiple channels. In WMN, communication is focused on more than one hop rather than single hop with the help of MAC. Multi-point to multi-point communication is possible with the help of distributed MAC. Self-healing and self-organization of node are the prime requirements of WMN for better performance. Communication between the node and the node which are located far, multi-hop distances, from the source node should be proper for providing better stability. Even less mobility influences the system performance of MAC. MAC protocol is designed in such a fashion that WMN can work simultaneously with both single and with multiple channels. Though various routing protocols are available for ad hoc networks, it cannot be directly used for wireless mesh networks. It is still a big research to perform modifications of the available protocol to be adopted for WMN. There are the same salient features that WMN should provide, with which are various performance metrics, scalability, robustness, energy-efficient routing algorithm suits for mesh network, various performance metrics, scalability, robustness, energy-efficient routing algorithm suits for mesh network. Various routing algorithms in a ad hoc network are available with any one of the above features, but not with all, which makes it difficult to adopt with the mesh network. Some of the routing concepts for mesh network are as follows. In Mr. LQSR, a metric called weighted cumulative expected transmission time, WSIT, is used for measuring the system performance. In WSIT, link quality and minimum number of hop counts are considered as a system metric which results in better throughput and less delay. The objective of multipath routing is to provide load balancing and fault tolerance. Between the source and destination, multiple paths are predicted. When the shortest path link breaks, it can be easily switched over to other available paths. This results in better system performance by reducing the waiting time for computing the path at the time of fault. It also improves throughput and reduces end-to-end delay and fault tolerance. Still, complexity exists with the multipath routing as it has to keep record of multipath always even if there is no breakage or fault. Hierarchical routing protocols show better performance when there is dense number of nodes in the network. This is due to fast setup procedure, reduced overheads, and shortest routing path. Complexity is higher on maintaining the hierarchy and directly relates to the performance of the system. It is a unique routing scheme in which it forwards the packets with the knowledge on the position of the node which is being communicated instead of the topology-based method. Geographical routing algorithm, single path greedy routings, finds difficulty in delivering the data, if the path is available between source and the destination as data forwarding with the help of current location information. Data delivery is guaranteed by using planar graph-based geographic routing algorithms but results in more overhead information. A large number of transport protocols are available for ad hoc networks, and WMNs depend on those transport layer protocols. Till date, there is no transport protocol that has been proposed specifically for WMNs. We know that ad hoc network is also not mature. It also has various unresolved issues. This suggests further research in this area. WMN supports enormous applications which include Internet access, distributed information storage and sharing, information exchange across multiple wireless networks, Internet access, distributed information storage and sharing, information exchange across multiple wireless networks. Various research works have been carried out under these domains but focusing on modifying the existing application layer protocol by adapting various features for the mesh application layer protocol. WMNs have their merits and drawbacks too. There are some issues to be concentrated for improving the network performance which include connectivity, radio range, interoperability, compatibility, etc. The weak area of WMN is security. Strong research is demanded due to the absence of centralized authority or key management for assuring security to provide fully trusted system. The common issues in WMNs are channel capacity expansion, scalability, and quality of service.